All right, everybody, for today's video, we've got polynomial division. Okay, busy, gotta go. Let's divide each f of x polynomial by the divisors d of x and write summary statements. All right, so just like a long division with integers, we're going to take the dividend, put it in this division bar, divisor outside, and now it's going to look similar but slightly different. First thing, we're going to divide. We always divide first term by first term. X to the fourth divided by x squared is x squared. So we put it specifically above the x squared term of the dividend. After we divide, we multiply. X squared times x squared is x to the fourth. X squared times 2x is 2x cubed. X squared times negative 1, negative x squared. After we divide and multiply, we subtract. This minus this is always going to be 0. Negative 2x cubed minus 2x cubed is negative 4x cubed. 3x squared minus negative x squared is positive 4x squared. And then we bring down the minus or negative 4x. And we repeat. So divide again. Divide first term by first term is going to be negative 4x. Multiply just this term, negative 4x, by the divisor. Negative 4x times x squared, negative 4x cubed. Negative 4x times 2x, negative 8x squared. Negative 4x times negative 1 plus 4x. All right, everybody doing good so far? We subtract, again, 0. 4x squared minus negative 8x squared, 12x squared. And negative 4x minus 4x, negative 8x. Bring down again. So we can always just bring down one more term and continue the division. First term by first term, 12x squared divided by x squared is 12. Multiply 12 times this whole polynomial. Speed, run. Subtract. So negative 8x minus 24x is negative 32x. 6 minus negative 12 is 18. And now we know we're done because we have something where if we try to do this first term by this, it would no longer be a polynomial, right? X to the first divided by x squared, no good. So this is our remainder. So our final answer, you could say our quotient is this, but it says write a summary statement. So there's two ways you can write this. The polynomial way is to say, we've just shown that this original f of x is equal to our divisor, x squared plus 2x minus 1, times the quotient, but we've got a remainder. That's the polynomial. The original f of x is equal to this. I'll come back and write the other one because I know you guys are impatient to see the second one. So notice this one is going to be a little different because we're missing an x term. We'll see how that affects things later. But right now, just begin by putting the dividend inside again, and let's go for it. X to the fourth divided by x squared. Multiply x squared times x squared is x to the fourth. Now, here's where we got to slow down, be careful. Because x squared times 1 is x squared. We can't put it here, it wouldn't line up with the power. X squared times 1 is here, x squared. So that means we should put a nice little place value holder to show there's no x cubed term. So when we subtract, that goes away, of course. Negative 3x cubed minus 0x cubed is just negative 3x cubed. 6x squared minus x squared is 5x squared. Then we repeat as normal. Oh, sure, we should bring down 3x. Repeat as normal. Negative 3x cubed divided by x squared is negative 3x. Multiply. Again, negative 3x is going to go here. We have no x squared term. Subtract. Negative 3x minus negative 3x is 0x. So we might have something interesting here. 5x squared divided by x squared plus 5. 5 times x squared. 5x squared plus 5. No 0x term. Look at that. What does that show you? That shows you that x squared plus 1 is a factor of f of x. So when we write our polynomial summary statement, and we say the original f of x is actually equal to our divisor times our quotient with a zero remainder. Evidence from the calculator. Factor this polynomial. Boom. 2 quadratic factors. So we've factored the 4th degree polynomial into a 2nd degree times a 2nd degree. This is the polynomial summary. The fraction summary is just saying, well, what if we divide both sides by the dividend? What is f of x divided by x squared plus 1? It's this thing divided by x squared plus 1, which is just our quotient. So going back here to write this fraction summary statement, f of x divided by the divisor equals this whole thing divided by the divisor, so that will cancel out. And we'll just be left with the quotient. And then the remainder, how do I want to write this? I think I'll write it like this. Divided by divisor. All right, done and dusted. But let's go back for a quick recap. So big things to remember: lining up place value. Big things to think about is, what is this saying? They're saying that this 4th degree polynomial divided by this 2nd degree polynomial gives you a 2nd degree polynomial. So, right, f was a 4th degree. You get the product of 2 2nd degrees, but this had a remainder. When you try to factor f of x here, notice nothing happens because it has no real factors. So the d of x did not fit evenly into f of x, hence the remainder. Hence, if we divide both sides by the divisor, you get your quotient plus this remainder statement. Whereas here, d of x did fit into f of x with no remainder. So our polynomial statement has no plus or minus at the end. It's just original 4th degree polynomial f is a 2nd degree times a 2nd degree. Nice. And so if we divide the 4th degree polynomial by the divisor, all we get is that. Pretty nice. All right, perhaps in the future I'll do a synthetic division because that's a little nicer. But actually, by the way, could you do either of these with synthetic division? I don't think so, because these are 2nd degree and synthetic division needs 1st degree divisors. Maybe we'll talk about that later. All right, don't forget to keep asking questions, and as always, go blue.